Hi everyone. Now we are going to start lecture 9 of current electricity. The topic is electric power and electric energy. So what is electric power? The rate at which work is done by the EMF, by the source of EMF to maintain the current through the circuit is called electric power. The rate at which work is done to maintain the current in the circuit by the source of EMF, that is cell or battery. तो सेल और बैटरी जो वर्क डन कर रहे हैं टू मूव द चार्जेस, जिस रेट से वो चार्जेस को फ्लो करवाएंगे, मूव करवाने में जो वर्क डन होगा पर यूनिट चार्जेस, पर यूनिट टाइम, दैट इज नोन एज इलेक्ट्रिक पावर, राइट? In the starting of the lecture, we discussed that how current flows through the conductors. Through the conductor, when we connect a battery, that means we provide the potential difference per unit length. Due to which that potential difference, there is work done on the charges to move them. So this rate of doing work by the cell or by the potential difference per unit time is known as electric power. We can also define it by the another definition, that is the rate at which an electrical appliance convert electrical energy into other forms of energy is known as electric power. We denote the electric power by the letter P. So P is equals to work done per unit time, rate of doing work na, to maintain the current in the electric circuits. So it is equals to VI. It is equals to VI or I square R or V square over R. So we have three formulas for electric power. P is equals to VI, product of potential difference and current, I square R and V square upon R. According to the given values in the numerical, which formula we going to use, it depends on the given values. So power has three formulas: P is equals to VI, P is equals to I square R and P is equals to V square upon R. It is a scalar quantity. Power is a scalar quantity. Its SI unit is watt, right? Its SI unit is watt. And also the power is given in kilowatt or megawatt. So 1 kilowatt is equals to 10 raised to the power 3 watt and 1 megawatt is equals to 10 raised to the power 6 watt. And how can we define 1 watt? One watt is equals to 1 joule upon 1 second. When 1 joule of work is done to move the charges by the source of EMF in 1 second, then the power is known as 1 watt. Right? Next, there are some other units, like there is also another unit, that is horsepower. 1 horsepower is equal to how many watts? 1 horsepower is equals to 746 watt. This is also very important conversion. 1 horsepower is equals to 746 watts. And also there is conversion. So these are the some basic units in which watt is to be converted. Next, there is a numerical. Calculate the power of an electric circuit consisting of resistance 3 ohm. What we have given, write the given values, and then according to the given values, which formula among the three we gonna to use. So what we have given is resistance is equals to 3 ohm and current is equals to 4 ampere. And the formula for power is VI, I square R and V square upon R. R and I are given. So we're going to use I square R. So putting the required values, I square, 4 square, that means 16 into 3. So it's 48 watt. Right? This is how we can find the power. And when we talk about heat energy, we also derive the formula for the heat energy in Joule's law of heating. H is equals to I square RT. What is I square? We can put power here, right? So H is equals to P into T is also heat energy, right? So H is directly proportional to the power. So remember it also. Next, some more points about power. If we talk about power, now there are 3 categories of power. Like if we classify that, or we can categorize the power. Power is, maybe we can say, it is of 3 types. Number 1, the rated power or the rating power. Another name is power weightage, weightage power. Second one, is consumed power. Consumed or dissipated power. And third one is effective power, or the net power of combination of the appliances or devices. Effective power. These are the 3 types, or these are the 3 ways to find the power. Number 1 is rated power. Every electrical appliance has its power rated on it. Just like we can say the bulb is of 40 watt. So it is its rated power, or the weightage power we can say. Right? But when we connect it across a power supply, how much power it consumed, it may vary. So that power is known as power consumed. How much power it consumed or how much power it dissipated, that is a consumed power or dissipated power. Effective power is like that, if we connect 2 or 3 bulbs, 2 or 3 electrical appliances across a power supply, then what is the net power across the series combination or the net power across the parallel combination? That is known as effective power. Okay, now we talk about one by one. So, rated power, you understand now? So, with example, I'll explain these things. Number 1, we talk about the rating power. Rating power. If we have 2 bulbs, B1 is equals to, or bulb 1 having power 40 watt, and there is another bulb B2 having power 100 watt, right? Connect them with the power supply of 220 volts. Both are connected with the power supply of 220 volt. Then firstly, what we have done, we have find their resistance. How much resistance they offer. So R is equals to, the formula for power is, if we have given potential difference V, and we have to find the resistance. Then which formula we going to use? P is equals to V square upon R. So R, we have to find resistance now. We have given power and potential difference. It's a V square upon P. So R is equals to, power is 220 volt. So 220 square upon power 40. 0 is cancelled by the 0. It's being 1110 and it's 11. Right? So what is the value of resistance in case of bulb 1? We consider it R1. It's 1 to 1. The square of 11 is 1 to 1 and it's 0. Right? So 1210 ohm is the resistance of the bulb 1 having 40 wattage power or 40 rating power. Both have the similar meaning, wattage power or the rating power. Now, in case of 100 watt power, we find the resistance in the similar way. So here resistance is equals to V square upon P. So 220 into 220 upon 100. 0 is cancelled by that zeros, and 22 into 22 is, it's 484 ohm. This is R2, right? So as this shows that this is seen now. The bulb 1 having less wattage power has greater resistance, right? But bulb 2 having greater rated power, having less resistance. You see now? Less power, if rated power is less, it has higher resistance. अगर 40 वॉट रेटेड पावर थी, उसका रेजिस्टेंस ज्यादा आया 1210 ओम, लेकिन सेकंड केस में जिसकी रेटेड पावर 100 थी, ज्यादा थी जिस बल्ब की रेटेड पावर, उसका रेजिस्टेंस कम हुआ. तो फ्रॉम दैट एग्जांपल व्हाट वी कंक्लूडेड दैट रेटेड पावर इज इनवर्सली प्रोपोर्शनल टू द रेजिस्टेंस. If the question asks that what is the relation between the rated power and the resistance, so we can easily conclude it by this example that rated power is inversely proportional to the resistance, right? Of bulb having 40 watt power, which is less, has greater resistance, but in case of rated power 100 watt, which is greater, has less resistance, which is 484 ohm. Understand this now? So rated power is inversely proportional to the resistance, whether the appliances are connected in series combination or in parallel combination. So it will be same for both. So here in the table, what we can write, that rated power is inversely proportional to the resistance. Remember it na? Agar if in a question you have asked that by just seeing the resistance, by just seeing the rated power, you have to calculate the resistance, that whose resistance is greater. So without wasting the time, we can easily give the answer that the less rated power has greater resistance, right? So rated power is inversely proportional to the resistance, whether it is series combination or the parallel combination, right? Next we have consumed power. We have second one is consumed power. Or another name of it is dissipated power, या power dissipated. Right? We can calculate with the three formulas: P is equals to VI, P is equals to I square R, and P is equals to V square upon R. The power consumed by the appliances. It is the power consumed or dissipated by the appliances. Right? The power consumed by the appliances. What power they gonna to use? Like when they connected in series and parallel combination. If they connected in series combination, so what we have to remember, when the two or more appliances connected in series combination, then which power they gonna to consume? In series combination, what we have remembered, that current remains same, potential difference is different across the different appliances. We have done this concept when we do cells in series parallel, resistors in series parallel, capacitors in series parallel, right? So current remains same across each electrical appliances when they are connected in series combination, and potential difference remains same when two or more electrical appliances, two or more electric bulbs connected in the parallel combination, right? So here we use a formula I square R, as current remains the same through each electrical appliances. So P is directly proportional to R. P is directly proportional to R here. Same in parallel, we use the formula V square by R. Why only use, we can use only this formula? Because the potential difference in parallel combination across each electrical appliance remains same. So V remains same, that's why P is inversely proportional to the resistance. Right? So in series, power is directly proportional to the resistance. So the electrical appliance which has higher resistance produces higher power. Its consumed power becomes high, right? That means it glows brighter. It glows brighter and also fuse firstly. The electrical appliances or the bulb whose resistance is greater and they are connected in series, I'm talking about the series combination. So the device or the appliance whose resistance is greater has higher power, has higher consumed power, and it glows brighter among all the electrical appliances. And it firstly fuse, सबसे पहले जो fuse होगा, that is the electrical appliances having the higher resistance. Okay. In case of parallel, as power consumed is inversely proportional to the resistance, so the electrical appliances having less resistance has more power, is brighter glow, is glows brighter, and fuses firstly, and produces heat amount of energy greater. Here the higher resistance produces higher amount of heat energy. Now understand? Now in case of the example, we take 40 watt rated power and the 100 watt rated power. So when 40 watt and 100 watt rated power are connected in the series combination, then which bulb glows brighter? The question will be asked that among 40 watt and 100 watt, which one glows brighter, or which one has greater consumed power, or which one produces greater amount of heat energy, and which one fuse firstly. So these are the questions which may be asked from that concept. So 40 watt, the resistance we find now 40 watt across 220 volt power supply. So the resistance here is, what is the resistance in that case? 1210 watt. and in case of 100 watt, it is 484. It is 484 ohm na, its resistance. So 40 watt has higher resistance between these two. So the resistance, the device which has higher resistance produces higher consumed power. It glows brighter, it fuses fastly, and it produces a greater amount of heat energy in comparison to the other electrical appliances. So in this case, 40 watt bulb which has higher resistance, it glows brighter and it produces greater amount of heat energy and it fuses fastly between these two. But when these connected, these same bulbs connected in the parallel combination, similarly 40 watt and 100 watt with the 220 volt power supply. So the electrical appliances which has less resistance, so which has less resistance between 40 watt and 100 watt, 100 watt na? So here 100 watt bulb or the 100 watt electrical appliances produces greater amount of power. Its power consumed is greater, it glows brighter, it fuses fastly, and it produces greater amount of heat energy than the other one. So by just saying the rated power, we can see, or we can just mark the consumed power, that it how much power, if the comparison is there. The question is just because of the comparison. So we can just simply say the device or the electrical appliance is having less rated power, its resistance is high, and H is directly proportional to R, or the power is directly proportional to R in case of series combination. We have to see whether they are connected in series or in parallel. तो सबसे पहले देखना पड़ेगा कि वो series में है या parallel में है. If the less rated power electrical appliances has greater resistance, so it glows brighter if they are connected in series combination. It produces greater amount of heat energy. But when they are connected in parallel combination, the device having higher rated power, which has low resistance, its power consumption is high, it glows brighter, it fuses fastly, and also produces a greater amount of heat energy. So in this case, heat energy is directly proportional to R. जिसका resistance ज़्यादा होगा वो ज़्यादा heat energy produce करेगा. But here the heat energy is inversely proportional to R or inversely proportional to power. ठीक है? Power is inversely proportional to R. Power के directly proportional होगी heat energy. But यहाँ पे heat energy resistance के directly है और यहाँ पे inversely है. So what you have to remember, power consumed. We have series and parallel combinations. In series combination, जिसकी rated power कम है, जिसका resistance ज़्यादा है, उसकी power ज़्यादा होगी, वही ज़्यादा heat energy produce करेगा, brighter glow करेगा, and it fuses fastly. ठीक है? Example we took 40 watt. And in parallel, consumed power is inversely proportional to the resistance here. Here, consumed power is directly proportional, right? In series combination. In parallel combination, it is inversely proportional. So the device which has less resistance, जो higher power का था, higher rated power का जो appliance था, जिसका resistance कम था, which consumed higher power consumed, it produces higher heat energy, it glows brighter, right? So this will happen. Next, now if we have 3 heaters of 100 watt, 220 watt and 500 watt connected in series, across 220-volt power supply. So these are the rated power. ठीक है? The question asked is that which one produces greater amount of heat energy? Greater amount of heat energy. Similarly, the question may be asked that in case of bulbs, there are 3 bulbs connected, having any 3 rated powers connected in the series combination or maybe in the parallel combination. Which one glows brighter, or which one produces greater amount of heat energy, and which one fuses firstly? Yeah, whose consumed power is greater? These type of questions will be asked from this concept. So here, the question is, we have 3 heaters. H1 is equals to 100 watt, H2 is equals to 220 watt, and H3 is equals to its 500 watt. As we discussed that rated power is inversely proportional to the resistance, whether it is series combination or the parallel combination, right? So whose resistance is greater? Whose rated power is less? So among these 3, 100 watt is a has the less rated power, so its resistance becomes high among these 3. They are connected in series combination. So in series combination, power consumed is directly proportional to the R. That means 100 watt heater produces or consumed more power. That means it produces greater amount of heat energy. Heat energy is directly proportional to R, or the power in the series combination, है ना? So it produces the greater amount of heat energy. So it is not needed to solve the whole question. It consumes a greater amount of time. So by these concepts, we can save our time. So just by saying that, okay, less rated power, that means it is inversely proportional to the resistance, whether it is series or parallel combination. And if they are connected in series combination, ये भी देखने की जरूरत नहीं है. You have to just see that in series combination, the electrical appliance whose rated power is less, that produces greater amount of heat energy. तो सबसे कम rated power है 100 watt हीटर की. ये सबसे ज्यादा इलेक्ट्रिकल पावर जो है वो प्रोड्यूस करेगा, यानी कि हीट एनर्जी भी सबसे ज्यादा प्रोड्यूस करेगा. So these are the questions that may be asked, and these are very important, right? Now the another one question, you do it by yourself. If we have 3 bulbs, if we have 3 bulbs, they are connected with 220 volt power supply. It is of 40 watt, it is of 60 watt, and it is of 100 watt. Then which one glows brighter? Which one glows brighter? So this is an assignment for you. Next, we have effective power. Third one we left now. That is effective power. So effective power is a net power. अब तक तो हम इंडिविजुअल पावर फाइंड आउट कर रहे थे, कंज्यूम्ड पावर फाइंड आउट कर रहे थे ऑफ इंडिविजुअल इलेक्ट्रिकल अप्लायंसेस, but effective power is the net power of the whole combination, whether it is series or parallel. So what you have remembered, in case of series combination, as we know, in series combination, power is inversely proportional to the resistance, right? So in resistance, in series combination, how can we find the net resistance? R is equals to R1 plus R2 plus R3. So the net effective power in series combination is equals to 1 upon effective power is equals to 1 upon P1 plus 1 upon P2 plus 1 upon P3. If we have three electrical appliances connected in a series combination, like 3 bulbs connected in series combination across a 220 volt power supply, end to end they are connected. So what is the formula in series combination of effective power, of net power? 1 upon. So the net effective power in series combination, the reciprocal of the net effective power or the reciprocal of the effective power is equals to the reciprocal of the sum of the reciprocals of the individual powers of the electrical appliances in series combination. So 1 upon P effective is equals to 1 upon P1 plus 1 upon P2 plus 1 upon P3. Similarly, in parallel combination, you understand how it comes, because power consumed is directly proportional to but the rated power is inversely proportional here. That's why. So from there it comes. But in parallel combination, what is the formula used? Effective power is equals to net or effective power of the whole parallel combination is equals to the sum of power of the individual electrical appliances, P1 plus P2 plus P3. Right? This is the formula for effective power. So in that diagram, effective power in series combination, formula for effective power in series, here in parallel. So 1 upon P effective is equals to 1 upon P1 plus 1 upon P2. Here P effective is equals to P1 plus P2. Right? So this is the formula for effective power. If we have 2 bulbs of 24 watt, V1 is equals to 24 watt and V2 is equals to 40 watt, connected in series, across 220 volt power supply. Find effective power of the combination. So how can we find the power, the effective power? As we have discussed that in series combination, the formula for effective power is equals to 1 upon effective power is equals to 1 upon P1 plus 1 upon P2. We have powers given, it's 24 watt and 40 watt. So 1 upon effective power is equals to 1 upon 24 plus 1 upon 40. So by taking the LCM, we can find the effective power. What happened when the question has given the resistance and the potential? So by that, we find their individual powers and then applied those powers in this formula, right? So it is assignment for you to find if we have two bulbs of 24 volt and 40 volt, they are connected in the parallel combination. You have to find the effective power of the whole combination, right? Next, we have electrical energy. Electrical energy is the total amount of work done by the EMF to maintain the current in the electric circuits for a given time. It is known as electrical energy. Electrical energy is equals to work done. As we have discussed in the electric power is rate of doing work, at which rate charges are moved to maintain the current in the electric circuit by the cell. But electrical energy is the work done to move the charges from one point to another point to maintain the current in the electric circuit by the EMF for a given time. That is known as electrical power. It is equals to work done. Power into time. We use the three formulas which we discussed in power. VI multiplied by T, I square R multiplied by T, V square by R multiplied by T. The SI unit of electrical energy is joule. Any energy, whether it is kinetic energy, potential energy, electrical energy, all have same SI units, that is joule. But every energy has its own practical or the commercial units. Like in case of heat energy, its practical unit is calories. But in case of electrical energy, its commercial unit is kWh, kilowatt hour. So 1 joule is equals to 1 volt into 1 ampere, 1 volt for potential difference, 1 ampere for current, and 1 second for time. We can also, V up into I is power. So we can also write 1 watt into 1 second. Commercial unit of electrical energy is kWh, kilowatt hour. So if we have to convert it into joules, so 1 kWh is equals to 3.6 into 10 raised to the power 6 joules. Right? The formula for electric power is, electrical energy is power into time. Firstly, we have to find the power, then multiply it with the time. It is also a scalar quantity. So in question, we have given an electric bulb is glowing 8 hours per day. It has 10 ohm resistance and is connected with 220 volt power supply. Find electrical energy consumed by the bulb in 30 days. The readings that we have in our electric meters are of readings of electrical energy, which are in kWh, kilowatt hour. Like we consider 1 kilowatt hour is equals to 1 unit. We have units that are all electrical appliances consume 30 units in a month or 15 units. है ना, हमारे घरों में जो मीटर होता है उसमें जो रीडिंग आती है वो किस में आती है? kWh में आती है, यूनिट्स में आती है ना, कि आपने पूरे मंथ में कितनी यूनिट्स कंज्यूम की हैं सारे आपके घर के अप्लायंसेज ने. ठीक है, और 1 रुपए की 1 यूनिट की कॉस्ट, आप यहाँ से इस क्वेश्चन में आप कॉस्ट भी फाइंड आउट कर सकते हो. इफ 1 unit is equals to the cost of 1 unit is equals to 8 rupees, then what is the total cost, total bill the person should have to pay in a month? Calculate it quickly. How you calculate? What is the formula for electrical energy? E is equals to power into time, right? So power you have to find, R and V you have to given. Which formula you going to use? V square upon R. Then multiply by T. Put all the values. What is the value of V? 220 into 220 upon 10 time already in hours, because the commercial unit of electrical energy is equals to kWh. We measure the electrical energy in kilowatt hour. So we have to convert watt into kilo. Watt into kilo. For that we have to divide the equation by 1000. 1 kilo is equals to 10 raised to power 3. है ना? So we divide it by 1000. And time is already in hours. 8 hours na? If it is in seconds, convert it into hours. And it is for 1 day. What we have to find? We have to find it for 30 days. है ना? So multiply it with 30 also. Tell me what is the value? What is the value? Find it. How many units are there in 1 month? 22 into 22. 484. 484 into 24. Multiply 484 with 24. Then divide by 10. 484 into 24. Quickly. 484 into 24 is equals to 116 upon 10. So 1161.6 kWh. Okay? So these are the units for 30 days. If the bulb is glowing for 8 hours and the cost is, this is for one, these are 1161 units. The cost of 1 unit is equals to 8. तो मल्टीप्लाई दिस विथ 8. ठीक है, अगर आप इसको इतनी यूनिट्स को 8 से मल्टीप्लाई कर दोगे तो दिस इज द अमाउंट दैट यू हैव टू गिवन इन 1 मंथ फॉर द कंजप्शन ऑफ एन इलेक्ट्रिक बल्ब having 10 ohm resistance which is connected with 220 volt power supply, right? So hence we can find the electrical energy. There may be possibility that power is given, power is already given, power given hoti to multiply that power with the time directly, right? So these are the concepts: electrical energy and electric power. Summarize the important one once. So we have 3 types of power: rated power or consumed power, rated power or weightage power. Second one, consumed or dissipated power. Third one, effective power. Rated power or weightage power is inversely proportional to the resistance. 40 watt, among 40 watt and 100 watt, which one has greater amount of resistance? 40 watt. Inversely ना, तो जिसकी रेटेड पावर कम है उसका रेजिस्टेंस ज्यादा होगा. तो 40 watt offers higher resistance, right? Consumed power or power dissipated, if we have to find, there may be in series or parallel combination. In series combination, power consumed is directly proportional to R, and in parallel combination, power consumed is inversely proportional to R. If we have given 100 watt electric bulb and 200 watt electric bulb, they are connected in parallel combination, then which one glows brighter? 100 and 200 watt. 200 watt. पैरेलल कॉम्बिनेशन में जिसकी रेटेड पावर ज्यादा होती है, तो 100 और 200 में से किसकी ज्यादा है? 200 की. तो वही उसका रेजिस्टेंस कम होगा, वो पावर कंज्यूम्ड ज्यादा करेगा, हीट एनर्जी ज्यादा प्रोड्यूस करेगा, ब्राइटर ग्लो करेगा, और सबसे पहले फ्यूज भी वही होगा. तो क्वेश्चन में बी आस्क्ड दैट व्हिच वन among the given powers fuses firstly or glows brighter or produces greater amount of heat energy or produces greater amount of power consumed, and whose have greater amount of resistance. These are the question that may be asked. 5-6 क्वेश्चन हैं, उनमें से कुछ भी पूछा जा सकता है, right? Next, third, we have effective power. The effective power of series combination, when the 2 or more electrical appliances are connected in series combination. So effective power is equals to 1 upon effective power is equals to 1 upon P1 plus 1 upon P2. And in parallel, effective power is equals to P1 plus P2. Understand? So here we end.